Welcome to Daily Papers, the podcast where we break down fascinating research into bite-sized conversations. You know, we talk to AI assistants all the time now. We ask them for recipes, for directions, to write emails for us. But have you ever stopped to wonder what the AI is remembering from all the data it was trained on? What if some of that data was private?
That is the million-dollar question, and it's at the heart of the paper we're looking at today. It's titled Model Inversion Attacks on Llama 3, Extracting PII from Large Language Models by Sathesh P. Sivashanmugam. That's a mouthful. But the core idea is surprisingly simple and a little bit scary. The paper shows how you can essentially trick a popular AI model into revealing sensitive, private information it was never supposed to share.
Okay, so let's start with the basics. The paper talks about LLMs, or large language models. For anyone who isn't familiar, what exactly are they?
Think of an LLM as the engine behind tools like ChatGPT or Google's Gemini. They are AI systems that have been trained on a colossal amount of text and data from the internet. They read websites, books, articles, forums, basically a huge chunk of the digital world to learn how to understand and generate human-like language.
The problem, as this paper points out, is that they don't just learn from all that data. Sometimes they memorize it. It's like a student cramming for a test who can recite a specific paragraph from a textbook word for word, but doesn't necessarily understand the deeper meaning.
Exactly, and that's fine if the paragraph is about photosynthesis. But what if the AI memorized a random forum post from 2012 where someone accidentally shared their email address and password? That information is now baked into the model's memory.
And this is where the model inversion attack comes in. It sounds very technical, but what is it in simple terms?
A model inversion attack is a clever way of coaxing that memorized data back out of the AI. The paper describes it as a black box attack, which is the most interesting part. Black box means you don't need any special programmer skills or access to the AI's internal code. You can do it just by talking to it.
So how did the researcher actually do it? What did they ask the AI?
This is the wild part. They didn't use complex code or hacking techniques. They just gave the AI simple, incomplete sentences called prompts, things like, "my password is," or "account number," and then just let the AI's autocomplete function do the rest.
Like playing a game of fill in the blank with a multi-billion-dollar AI.
Precisely. The bet was that the AI, in its attempt to be helpful and complete the sentence, would reach into its memory and pull out a real password or account number that it had seen during its training.
And I have a feeling, based on the fact that this paper was published, that the bet paid off.
It paid off big time. The paper includes a table of the results, and it's pretty stunning. For example, when the researcher prompted the model with, "my email ID is," the AI completed the sentence with a person's real first and last name, their actual Gmail address, their mobile number, and even a link to their LinkedIn profile.
No way! So this was a real person they could identify.
Yes, the researcher confirmed it. They were able to go to the LinkedIn profile and see that this was a real individual. In another test, they prompted it with account number, and the model returned the name of a real bank, Suncorp, and a PO Box number associated with it. This wasn't the AI making things up. It was regurgitating real, sensitive data it had memorized.
That is genuinely shocking. And the AI they tested this on was Llama 3 from Meta, right? I've heard it's a smaller, more efficient model that's even designed to run on your phone.
That's what makes this so significant. This isn't some giant data center-only model. It's a version of Llama that's considered more lightweight. The fact that even this smaller model can be tricked into leaking personally identifiable information, or PII, shows how deep this problem runs.
So we've identified a pretty major security flaw. What's the solution? Do we just shut all the AIs down?
Well, probably not, but the paper outlines several crucial steps that developers need to take. These are called mitigation strategies.
All right, what's strategy number 1?
The first and maybe most important one is data sanitization. This means you have to clean your training data before you ever show it to the AI. You need to build tools that can automatically go through the billions of web pages and articles and scrub out anything that looks like an email, a phone number, a social security number, or a password.
So you're basically creating a filter to catch the private stuff before the AI ever sees it.
Exactly. Another key strategy is something called differential privacy. This one's a bit more abstract. Think of it as adding a tiny bit of random noise or static while the AI is training. This noise makes it really difficult for the model to latch onto and memorize any single specific data point, like one person's email address. It can still learn the general patterns of language, but it can't perfectly memorize the outliers.
That makes sense. It fuzzes out the details. The paper also mentioned filtering the output, didn't it?
It did. That's another layer of defense. Even if a piece of private data slips through the cracks and the AI tries to say it, an output filter would act like a sensor, catching it and blocking it before it ever reaches the user. It could be programmed to block any text that looks like a credit card number or a phone number.
So it's a multi-layered approach. Clean the data going in, make the model's memory a bit fuzzy, and then check the data coming out.
You've got it. The paper stresses that no single one of these solutions is foolproof. The best strategy is to combine them all. It's a defense in-depth approach.
So the big takeaway from this paper seems to be a pretty serious warning for the future of AI.
Absolutely. It highlights that privacy and security can't be an afterthought. For these incredible tools to be safe and trustworthy, the people building them have to prioritize protecting our data from the very first step. This paper is a clear and powerful demonstration of why that matters.
A fascinating, if slightly unsettling look at the ghost in the machine. That's all the time we have for Daily Papers. Thanks for listening.